2004, a statewide committee comprised of 26 public and private educators began the process of reviewing and revising the Kansas State Science Standards. 8 members of the writing committee crafted the standards and presented them to the State Board of Education. They became known as the Minority Report. After much discussion, it was decided that the best forum to address the issues was via formal public hearings. However, some in the Kansas science community have called for a boycott of the hearings, and representatives of state and national science groups have refused to testify. The American Association for the Advancement of Science CEO Alan Leshner stated, "AAAS respectfully declines to participate in these hearings." And he added, "The concept of evolution is well supported by extensive evidence and accepted by virtually every scientist." AAAS emphasized, "There is no significant controversy within the scientific community about the validity of evolution." However, the 23 experts that testified disagreed. They detailed major controversies surrounding chemical evolution, the origin of life, macroevolution, the origin of new body plans, and biological systems and common ancestry. Additional controversies identified relate to the definition of science and the mechanisms of evolution. In May of 2005, 23 experts testified during 3 days of hearings. The experts included 5 PhD biologists, 4 PhD biochemists, 3 PhD chemists, 1 PhD geneticist, 1 PhD quantum physicist, 2 PhD philosophers of science, 1 PhD professor of education, 3 biology teachers, a Muslim journalist, and an attorney. Dr. Bill Harris has a Bachelor of Science degree in chemistry from Hanover College in Hanover, Indiana, and a PhD in nutritional biochemistry from the University of Minnesota. He was the developer of the Omega-3 Index, a new blood test to assess cardiovascular risk, for which he has gained international standing.
We have an obligation, we think, to teach origin science in the most neutral way possible, without religious bias, without naturalistic or philosophical bias. And that way we do the best science and we end up neutral with respect to the Constitution. In order to accomplish that, we require that all the data that's relevant, the scientific data that's relevant to the issues of chemical evolution and macroevolution, be put on the table. That the presentation of one side of that controversy, data supporting one side of that controversy, without the presentation of data that's contradictory to that hypothesis, is not scientifically acceptable and also biases the discussion. So in a word, our hope is that at the end of these hearings, we will be allowed to teach the controversy that does exist over origins. The strategy of our opponents has been to mischaracterize our position and actually to malign some of us who are presenting that position. They have consistently and remarkably, in my mind, refused to engage in a discussion of the scientific substance of the issue. Our opposition has chosen to fight this battle with name-calling. This is a posting on the Kansas Citizens for Science website, dated February 10th, 2005. It was written by Liz Craig, who is a member of that organization and involved with some of the public relations. My strategy at this point is the same as it was in 1999. Notify national and local media about what's going on and portray them in the harshest light possible as political opportunists, evangelical activists, ignoramuses, breakers of rules, unprincipled bullies, etc. There may be no way to head off another science standards debacle, but we can sure make them look like asses as they do what they do. Our target is the moderates who are not that well educated about the issues. Not that well educated. We're talking about education here. Most of whom probably are theistic evolutionists. There's no way to convert the creationists. the methods of natural investigation. They don't invoke spiritual forces to account for what they observe in the world. They look for natural causes. And I think that's fine to look for natural causes. But when you don't find any natural causes, it's time to fess up and say we don't know. Instead of saying, well, there was a natural cause, we don't know what it was, but we have faith that that's what happened. So methodological naturalism really puts blinders, I think, on the search for truth, particularly in the area of origin science.
Why in the area of origin science?
Because that's a historical science. It doesn't get much more historical than billions of years ago. Nobody was there to know what happened. Nobody watched it. We cannot say with any surety how anything came to be. Every experiment, particularly in the origin of life field, where they attempted to use, quote, natural environments to produce even some of the simplest chemicals of life, have consistently failed. Since 1950s, they have failed and failed and failed and failed, and yet they are still in the textbooks presented as the plausible explanation for how life arose. But those experiments have failed. It's dishonest, in my view, to portray failures in the laboratory as successes in a textbook. The tremendous amount of data in scientific literature, particularly in biochemistry, but also in cosmology and many other places, that points, that has identified, I think, certainly since 1953, when DNA was, the code was cracked by Watson and Crick. What Watson and Crick discovered was a code. They discovered a code. Every other code in the world that we know of came from a mind. To conclude that DNA at some level somewhere originally came from a mind is not an irresponsible deduction from the data. When we look at some of the biochemical machines that are in cells, and some of our witnesses will attest to this, and maybe even show some pictures. And now that we understand how some of these fantastically complex machines that work inside the simplest cells, we can see them now. We understand them now. The advance in modern molecular biology has shown us a world that can only be explained, in my view, by positing some kind of a plan in a direction. I don't know who did it. I don't know how it was done. I don't know why it was done. I don't have to know any of that stuff to detect design. If I walked into my garage today and I found a 6-foot bacterial flagellum laying there and spinning at 100,000 RPM, I would have no idea what it was, besides maybe my weed whacker gone nuts. But I would have no question in my mind that it was a designed object. I would just not know what it was. But you can infer design just by examining something without knowing anything about where it came from.
Why do many mainstream scientists, evolutionists, if you will, refuse to accept the idea that DNA is a code?
Oh, no, I don't think anybody refuses. I just don't think they think about it very deeply.
Okay.
I mean, everybody knows it's a code. I just, in my opinion, they haven't sat down and taken a deep breath and said, where did that come from? And really think about the fact that the bonds along the backbone of the nucleic acid are sugar phosphate bonds. Every bond is identical. There's nothing chemically that's different between the bond between an adenine and a glycine, or a guanine nucleotide containing a nucleoside. So the fact that they form this chain is kind of like letters on a page. The letters don't have to be in that sequence. When they are in that sequence, they communicate information, but they don't have to be that way. In the same way in DNA, the letters don't have to be in the sequence they are by any chemical reason, any law, any natural cause that we know of. Therefore, just like text in a book, the code in DNA has the fingerprints of intelligence. But the nature of that intelligence, the purpose of that, how it happened, I don't know. But I can come to a conclusion of, at least a tentative conclusion of design, without knowing anything about where it came from. If a Coke bottle fell out of the sky into an African desert, and I was a native, you know the movie I'm talking about, Gods Must Be Crazy. Those people knew that Coke bottle was designed, but they had no idea what it was.
Dr. Jonathan Wells is a senior fellow at the Center for Science and Culture at the Discovery Institute. He has 2 PhDs, one in molecular and cell biology from the University of California at Berkeley, and one in religious studies from Yale University. Subsequently, he has performed postdoctoral research at UC Berkeley and has authored 2 books concerning evolution.
Specifically, probably most notoriously, in 2000, I published a book, Icons of Evolution, in which I showed that many of the major images used in biology textbooks as evidence for evolution, in fact, do not fit the evidence. The one I first discovered was the picture of embryos, which I'll talk about in a few minutes, because I was studying embryology, and I would compare the pictures with the embryos I was actually looking at and realized that there was a discordance there. And I went on from there to study various other icons and found similar discrepancies between the icon and the evidence. Well, the peppered moth icon, which has pictures typically of peppered moths resting on tree trunks where we now know they don't normally rest, is used as evidence for natural selection. Well, I have no quarrel with natural selection, so I'm not saying that the falsity of that icon refutes natural selection. But for each icon that I deal with, what I do say, and I think legitimately, is that if this is thought or presented as some of the best evidence we have for Darwinian evolution, and so much of it is false, where does that leave the theory? Because sooner or later, if a theory is going to be scientific, you have to test it against the evidence. And if piece after piece of that evidence turns out to be exaggerated or distorted or even faked, then I think the theory itself at some point becomes suspect.
Your criticisms in Icons of Evolution tend to weaken evolutionary theory. Would you agree with that?
The evidence is what weakens evolutionary theory. I have no desire to weaken any theory except by comparing it with the evidence. What I don't want to weaken is science. But science thrives on comparing theory with evidence. I'm going to pick 7 phyla, 7 major groups. We're in the chordate group. If we look at the molecules in these organisms and we group them according to the similarity of their molecules, we can rearrange them thus. So the molecules here are most similar. They're more similar to each other than they are to these, for example. These are more similar than they are to those. So we can regroup these according to the similarities in this particular molecule. Now, if we construct a tree, an evolutionary tree, following Darwin's pattern, based on this molecule, we get something like this. But be clear that the only data we have are up here. We have the molecules from these organisms, and the rest of this is inferred based on the assumption that they share a common ancestor. What's interesting is when we look at these molecules, various discrepancies immediately appear. For example, the tree I just showed you from 18S RNA doesn't fit the classical tree that had been drawn on the basis of morphology or anatomy. Animals that are close together up here are far apart over here. Not only that, if I pick a different molecule, 28S RNA, I get a different tree again. Okay, here's the 18S tree, here's the 28S tree. Okay, once again, animals that are closely related by one are not closely related by another. Imagine if you found out that your grandfather was not the least bit related to you, but, related to people half a world away. I mean, this is pretty fundamental biology stuff, It matters who you're related to. Even worse, if we take 18S RNA and submit it to 2 different laboratories, as it was done in this case, again, we get 2 different trees. So the molecular evidence is shot through and through with discrepancies. A recent article in Nature shows that this controversy is continuing. These trees here, it shows these 2 trees in Nature. Here, we, the chordates, are most closely related to the arthropods, or the insects. But according to this other molecular study, we're way off here, and the insects are more closely related to roundworms. Now, these are not trivial issues in molecular or evolutionary biology. So, the inconsistencies in evolutionary trees based on molecular comparisons have to actually be explained away in the light of evolutionary theory. they actually don't provide evidence for the theory. Now, I'm not saying the theory is proven false, but this certainly doesn't provide evidence for it. Now, in Darwin's theory, this is a very simplified cartoon of it. The phyla that I showed you a few minutes ago are up here, and if we had a good fossil record, which of course we don't, we would expect to find something like this in the past, where these branch off somehow from a common ancestor that might be, for example, some form of worm. Ideally, this is what we would expect. When we go looking at the fossil record, what we find instead is this. Most of the major animal phyla appear abruptly, geologically speaking, in the Cambrian explosion, with no fossil evidence they actually came from a common ancestor. Theory versus evidence. Now remember, common ancestry might be true at lower levels, but at this level, the level of the animal phyla, the fossil evidence certainly isn't helping us. Darwin himself recognized this. He said this actually presented a valid argument. Suddenly appear in the Cambrian must at present remain inexplicable and may be truly urged as a valid argument against his view of common ancestry. I would argue, as a biologist, that the problem has not been solved in the intervening 150 years, at least not from the fossil evidence. The way Darwinian evolution is often presented as though there's overwhelming evidence for it and no dispute about it. Clearly that's not the case, so I do think students should be exposed at least in outline to these problems. What does it do to Darwin's theory? Well, I think it weakens Darwin's theory. The evidence weakens Darwin's theory. But for science, that's good. If the theory doesn't explain the evidence, then it should be weakened in the eyes of the students. They shouldn't be told something explains evidence that isn't there. They should be aware of the evidence. On the way down here was finally getting a chance to read a book. It came out in 2003. It's called Origination of Organismal Form. Now, these are eminent evolutionary biologists. As far as I know, there is not an ID proponent in there, certainly not a creationist. As far as I know, all of them have a faith that sooner or later completely natural explanations will be found for all these phenomena. But to a person, these writers say quite clearly that there's a problem extrapolating microevolution to macroevolution, a scientific problem. It's just undeniable. It's throughout the scientific literature.
You keep using the term Darwinian evolution. You would agree, would you not, that since Darwin, the science of evolution has advanced greatly?
Well, then I would include in that neo-Darwinian evolution, which is just Darwinism combined with genetics.
You keep using Darwinism and neo-Darwinism. Isn't it, in fact, the science of evolution that we should be speaking about and not using terms that are intended to simply draw a reaction? If we're interested in speaking about science?
I prefer to be precise. The problem is the term evolution, as several speakers before me pointed out, is vague. I mean, it can mean change over time. I've seen it defined in textbooks as a change in gene frequencies. Well, that's not correct. My children have different gene frequencies from mine, and they haven't evolved.
Please answer my question, Dr. Wells.
I'm trying to be precise about the definition of evolution.
It is true, is it not, that since Darwin 150 years ago, the science of evolution has advanced greatly. As an example, Darwin had no knowledge about genetics, did he?
No, he didn't. That's why I said neo-Darwinism is Darwin's theory combined with modern genetics. If someone could show me a mechanism whereby an ape-like creature could turn into something like a human, I would accept it. But I've looked and I haven't found it. Not even remotely close. When Newton proposed his theory of gravitation, it was dismissed as supernaturalism because it was action at a distance. What constitutes supernaturalism in today's science may very well not be supernatural in tomorrow's science. That's why I emphasize the process of testing hypotheses against the evidence.
I understand, sir, but there is a difference between looking at nature and asking questions versus looking at questions and because we cannot find an answer at the moment, assuming that it had to be an intelligent designer.
That's not how intelligent design works. Intelligent design is not an argument from ignorance. What it does is it sets certain criteria by which we normally, in the course of our daily lives, determine whether certain things are designed or not. And then it argues that that can be extended to features of the natural world. Obviously, that's a controversial claim, but I think it's a legitimate one.
With the hypothesis of neo-Darwinian evolution that there is common ancestry, why doesn't the analysis, the evidence that about the 18S RNA tree versus the 28S RNA tree falsify that? Why doesn't that do that?
In my opinion, because neo-Darwinian evolution has left the realm of science. It now functions as an assumption, an underlying given, a dogma. It cannot be falsified. Nothing will falsify it because it's just a given. It does make predictions. I would argue that virtually every prediction it has made above the species level has been falsified in the sense you just described. And yet the theory is still with us. And I would argue that that is evidence for its non-scientific nature.
We have a lot of people addressing us and saying, well, this is not science. And why? And when I say, well, I think it has scientific basis, they still argue that it's not science. Can you address any of that? Why is intelligent design science then?
Well, it's interesting. If you read the evolutionary literature, at least before the last few years when this started brewing more heatedly, Darwinian evolutionists have consistently argued against design. Darwin himself did. Hundreds of pages in The Origin of Species are devoted to arguing against design. The argument was the evidence will show that what looks like it's designed can actually be explained by natural processes. Now, if evidence can show that something is not designed, then in principle, evidence can show something is designed. You can't have it both ways. You can't say suddenly, well, you can't argue for design because all of a sudden that involves something supernatural. Darwin was excluding the supernatural and claiming that the evidence justified it. I would say if you're going to resort to evidence on one side, you can resort to it on the other. And for me, that's all intelligent design does. It says the evidence we see points to design. Where we go beyond that is a theological question. Well, I'm also a theologian, so I love those questions, but that's not science for me.
Dr. Bruce Samat earned his PhD in 1983 from the Department of Physiology at the University of Minnesota. For the past 11 years, he has taught courses at Northwestern College on biochemistry, human physiology, developmental biology, immunology, genetics, cell biology, and animal biology.
The students provoked me to know everything about evolution because they came up with so many questions. The textbooks were very dogmatic in their approach to evolution, especially macroevolution and origins. No one had any trouble in my class talking about microevolution and diversity. No questions come from that. Everyone's just amazed how well that works together. But everyone has questions about how macroevolution can work. I found 11 years ago that I couldn't answer that. Now, 11 years later, I still can't answer that. And I read everything. Some of the provocation coming from the students came from the wording within the textbooks. In the chapters, for instance, in genetics, when I teach that course, the wording, the verbs, if you will, used in describing mutations is very precise and very accurate and very declarative. They, with data, are able to declare that the mutations are deleterious, that there are insertions, deletions, etc., and that they cause problems with the function of that gene. And then when we get to the chapter on macroevolution, the question is asked, and this is pages later, chapters later, the question is asked, can macroevolution lead to new forms of life? And the answer in one word was certainly. And then all of a sudden, the verbs change to what I call soft verbs. No longer is it we know, we have tested, data shows. It is now should have could have, must have been. And my students picked up on that and wondered why all of a sudden there aren't declarative verbs here and everything is very soft in its wording. That was provoking me. I had to find out why. So I've been reading extensively, and the textbooks are written accurately. It is a lot of soft verbs. There has to be, because there's a lot of stories of how it possibly could have happened. But there is no data to back that up such that we can say we have tested or we have produced such a phenomenon.
We should be able to challenge that.
Yeah, and all things should be available for challenging. That has been part of my anger with science, is that nothing is sacred is the norm for all other disciplines except evolution. Then all of a sudden it becomes the sacred cow. I have had an occasional outburst in class by me when I'm lecturing, when I have to tell students that, by golly, when I did my master's research, thesis research, and when I did my postdoctoral research, and when I did 15 years in the companies with their research, everything is held up to scrutiny and skeptical analysis. Nothing is left untouched. Nothing is taken for granted. Nothing is taken on faith. Everything must be proven. Nobody else gets away with that. Peer review editors don't let you get away with that. In your conclusions, you say, and I speculate. You don't say, this is the truth because I made this story up. But not in evolution. My students coming out of a Christian college are now armed with all of evolution, exactly what it teaches, and exactly what its downfall is, or its shortcomings. They know what it can show, and they know what it can't show. I would say that they're probably better armed than their counterparts who are going to the University of Minnesota, who are not shown what, in fact, it can show and cannot show. So who has more knowledge and who has more accurate knowledge? Those who know what a theory can do and what it can't, or those who are just told the party line?
So true data, true conclusions. If we want quality education in Kansas, we should also teach evolution and its criticisms. Wouldn't you agree? Is that what you do at your school?
Well, for macroevolution and in origins, if you're going to teach just from the textbook and those tenets of what it should be able to do, then you're not actually teaching the story, the entire story of evolution. You're teaching a segment of it.
Okay, thank you.
Dr. Samad, I have been a proponent and stated earlier, and will state again, like your comment on it, of empirical science as defined by observable, measurable, testable, repeatable, and falsifiable. Would you comment on that?
Yeah. Well, the empiricism is the heart of science. And once you start leaving empiricism, it's okay, but you need to say it. And you need to know the difference between what's empirically and supportable and what is, in fact, become more of a story. I'm amazed at how well the reverse engineered stories look. They look very good, and they're very compelling of how they're engineered. But they are, in fact, engineered. And we don't have data, especially when it becomes a historical science. That's total engineering. We have fun with I actually brought photocopies of my textbook on general biology where they show the primordial soup. And so I was very entertained and bemused, as always. And it's very interesting, but there are so many tenets, thank you, there are so many tenets that have to be perfect for that to happen. And so it's written that way, that all these things would have to have fallen into place. That's wonderful. It makes very nice reading, but of course it's a historical science. It doesn't have any data.
Dr. Ralph Silke attended graduate school at the University of Minnesota and the Mayo Graduate School of Medicine, finishing his work for a PhD in microbiology in 1981. In 2004, he was a visiting scholar in the Department of Microbiology and Immunology at the Stanford University Medical School, conducting research to further our understanding of evolution.
Basically, what experimental evolution does is we use experimentation to ask very specific questions about evolution. And this comes from the fact that there's probably a dozen or so very well documented cases of evolution in bacteria. And typically those cases involve a gain of function where you're able to make able to use a food source that a microbe in the past was not able to use. And so you can do real experiments with evolution. In a day, you can produce 1 trillion organisms. So you can ask questions. Now, 1 trillion organisms is a lot of organisms. When you talk about human population, we're talking orders of magnitude more than the number of people who've ever lived on this planet. You know, since the beginning, wherever you want to determine that. So you can ask bacteria to do very, very specific things and find out, can they do it or can they not do it? So experimental evolution, and you can model time. One of my heroes is Richard Lenski at Michigan State, and Richard Lenski has been evolving bacteria for 35,000 generations. He does this. It's actually his technicians do this, but he takes 2 teaspoons of bacteria and he grows them in a medium that's low on glucose, and then after they've grown, he takes a 100th of that population and puts it in a new tube. You get 6.64 generations every day. He's been doing this for 15 years. You do the math. With a little work, you can model trillions of organisms and literally tens of thousands of generations. 35,000 generations puts you in the range of what human evolution, what is supposed to have happened in human evolution. So experimental evolution allows you to ask real questions about what evolution can do.
Is it fair then to say that while microevolution has been observed in the laboratory, macroevolution has not and is simply inferred?
Yes, I would say that's an accurate statement.
And the inference is drawn from what?
Well, the inference is, I think, you start with the assumption that nature is all there is, and this is all we have to work with, and therefore we're here, and there's nothing else that could have gotten us here, so therefore it must have worked, even though it doesn't look like it could work.
But you said you're starting with an assumption.
Yeah, you start with that assumption, and you know, if you start with the assumption, which is what methodological naturalism does, if you start with the assumption that nature is all there is, you will produce an explanation that comes out of nature. And if it's a bad explanation, go back to your assumption. You won't work beyond that assumption.
Do you have any general comment on the proposed changes that are contained in the minority report?
I think you'll have a group of students who will be much more aware. They'll have a better understanding of evolution. They will not accept it unthinking. Those who accept it will have accepted it in light of the criticisms. So they will be stronger because of that. Those who doubt it will know why they doubt it, rather than simply having been told to doubt it. And I think now this is a subject where being sure may not be the best thing you want. You may want people who don't know the answer, because that may be the better place. If you don't know something, and you know you don't know something, you're better off than if you don't know it and you think you know it. So I think you'll have a better educated population. The evolutionists don't ask these questions, because if you know that, I am what evolution can really do, you don't ask bacteria to evolve, because you know the answer right away. And so it's only when you step out of that paradigm and you say, well, maybe it doesn't have all the answers, that you even ask the question. And so that's why I think the skepticism of evolution is good for science. Evolution needs an opposing theory, because it'll just sit on its haunches and spin just so stories that everybody's happy with. And so that's why if you have someone from the outside saying it ain't necessarily so, And let's do some experiments where other people are happy just with just those stories. You are helping science.
Jill Gonzalez Bravo received her master's in curriculum instruction with an emphasis in science and technology from Wichita State University. She is currently employed in Rose Hill, Kansas as an 8th grade teacher, where she has served on a committee that has developed curriculum maps for science content.
I have been a teacher for the last 10 years, and though encouraged to boycott, I felt that this issue is not about me. It's about the students and their rights. And so that is what I'll be speaking to today.
Give me some examples and, what kind of feedback do you get from them?
Okay. During my 4 years of completing my area of focus in biology at Kansas State, I became very versed in the theory of evolution. I learned that it was an undebatable fact among many of my professors. I also caught on very quickly to the idea that, and this was a perceived idea, but that if anybody that believed differently, they were not considered a true intellectual. I was amazed the day the topics of origins came up within the class. It turned into a heated debate and a heated argument, I should say, with me as the target. This is where the conflict came into play. I have students who at first glance gave the impression that they cared very little about school and science, but somehow this topic was important to them. However, my previous education had taught me that there was no controversy. There was no data that supported evolution. It's not factual. I had never read anything to the contrary, so I had no idea how to lead or even whether I could allow the discussion to continue. I just wasn't sure. I was left with 2 questions to reflect on. First one, this is the teacher in me. Why does this topic evoke strong opposition from the majority of my students? And then why was I apprehensive about providing my students with the academic freedom to investigate and question what they perceive to be controversial? I felt as a professional that it was my duty to try to understand what about this topic of evolution these students oppose so strongly. Let's say that a student does not bring up the controversy surrounding the peppered moths in England, and therefore I don't, because as a science teacher, I have been encouraged not to do anything to weaken or diminish evolution by the National Science Teachers Association. What do you suppose the child will think when he later finds out this discrepancy surrounding this evidence? To me, it would do more harm to teaching of evolution as a unifying theory of science than to the teaching of science. The student will begin to question why they were lied to about this issue, or at least they will perceive deception. Whether it's there or not, that is their perception. And they'll wonder what else is untrue. There may be scientists that could explain this away, but as an educator, how are we to deal with these controversies being brought up in our classrooms? We rely on scientists to provide us with unbiased content for our classrooms. That's why we rely on our textbooks. This is our source of information and knowledge that we give to our students. I take issue with invalidating anyone's thoughts because they may be derived from a worldview counter to mine. This concerns me, and that is why, with much contemplation, I chose to speak today. This has not been exactly a career move to speak of, when so many have chosen to boycott. But I am here not to advance my own agenda, but to promote greater academic freedom for our children.
Dr. Edward Peltzer earned a Ph.D. in oceanography from Scripps Institution of Oceanography at the University of California, San Diego in 1979. For 20 years, he worked as a research specialist at the Woods Hole Oceanographic Institution.
So in fact, there are big problems with a scientific theory on the origin of life. Lynn Margulis, she says that to go from a bacterium to people, this is the biological evolution, is less of a step than to go from a mixture of amino acids to a bacterium. So the big problem is making life. Next slide. Heinrich Hauen has stated that the most reasonable interpretation of data is surely that life existed on Earth more than 3,850 million years ago. The significance of this number is that it's thought that at 4 billion years ago was about the first time that the Earth became habitable for any life. So you have a time period of 150 million years for life to form, or at most, if you go back to the formation of the Earth, maybe 500 million years. Next slide. In summary, there's no remnant or trace evidence of a prebiotic soup anywhere. If it ever existed, it is entirely conjectural. Although its emergence from non-living matter is hard to conceive, life appears almost immediately. There's almost no time for life to evolve into the simplest bacterial cells. And in spite of the idea of RNA or PNA worlds, there's no consensus on the model for precellular life. So the situation is so bleak that scientists want to begin to seriously consider the idea of directed panspermia. And this is the idea that some other civilization somewhere else in the universe sent out capsules to seed life throughout the universe. The problem with this as a scientific idea is that it puts the problem of how life began out of reach and out of touch. That's why it was dismissed the first time. The only reason it's being brought back the second time is they're having so much troubles trying to figure out how life began on the conditions of the early Earth.
My question is, sir, do you support the opinion of intelligent design as the answer to human species?
Yes, I think it's the one that's going to probably show to be correct.
And you would agree with me, would you not, that there are thousands of individuals who are scientists, who are able to do their scientific research and work, understand evolution for what it is, and not have their religious views threatened? You would agree with that, would you not?
No, I would not. Naturalism is a religious view, and people that are basing their interpretation of science and their doing of science on it are in fact practicing their religion. Those thousands of scientists are trying to impose naturalism on the rest of the public.
Dr. Russell Carlson received his Ph.D. in biochemistry from the University of Colorado at Boulder in 1978. He has authored and co-authored more than 125 articles in various peer-reviewed journals, has 3 patents, and has given invited lectures at universities throughout the United States, Europe, and South America. Dr. Carlson currently serves as Professor of Biochemistry and Molecular Biology and Adjunct Professor of Microbiology at the University of Georgia.
It's really inappropriate to restrict explanations to those that only support one metaphysical position, which is materialistic naturalism. And that's a position that nature is all there is. Science should be in a search for truth, and scientists, teachers, and students should be able to follow the evidence wherever it leads. It's not, in my opinion, appropriate to force all evidence into a 150-year-old Darwinian box. We need both teachers and students that are able to critically evaluate evolutionary theory and think outside the box.
Do you accept the general principle of common descent that all of life is biologically related back to the beginning of life? Yes or no?
No.
Do you accept that human beings are related by common descent to pre-hominid ancestors? Yes or no?
I don't accept that as scientifically proven fact, no.
But you are not suggesting that intelligent design is the answer.
Well, scientifically, I don't think that's been determined yet, no, but I think it should be one that's considered.
Do you have a problem with science attempting to find natural answers to the world around us?
Absolutely not.
Is it your suggestion that science should include intelligent design as a quest for truth?
I think it should be considered.
Dr. John Sanford holds a PhD in plant breeding, plant genetics from the University of Wisconsin in Madison, and is presently an associate professor of horticultural sciences at Cornell University. Dr. Sanford has authored over 70 publications and holds 27 patents.
Most of my career, I've been an atheistic evolutionist. Later in life, I became a theistic evolutionist, and later became a biblical Christian. And so I'm sure as the prosecutor will be asking me, I do have a Christian perspective.
I think you said that you were a theistic evolutionist for a period of time after that. Why was that?
I had been trained in evolution, and everything I'd ever thought was in terms of evolution. For me, it was as clear as that the world is round. It's just uncontestable. But in retrospect, I had not critically assessed much of what I believed. I believed it based upon authority, without critical assessment.
So, would it be fair to say that while you were an atheist, you didn't find any personal reason to critically analyze the theory or to challenge it?
As an atheist, there's no alternative hypothesis, because if no one, and there's no designer and no creator, then you have to believe that the universe created itself.
Do you use evolutionary biology in your operational science?
I don't use it, and when I was an evolutionist, I would have argued that evolutionary theory is critical to being a good scientist. I actually realized that some of my best science has been done since that time. I've also realized that historically all the founding fathers of science were non-evolutionists, and many of them were anti-evolutionists. So I realized that good science is not in any way conditional upon accepting the evolutionary theory.
And then at some point in time, something caused you to begin to question it.
I had friends who basically said, have you looked at the other side? And I said, what other side? I had been at Cornell at that point 20 years, and I really did not know that there was a legitimate position which could contest evolutionary assumptions.
And so then you began to look at it critically.
I began to look at it critically, and for several years I was intrigued by alternative explanations for many different things. And so this was a time of great intellectual excitement for me. So looking at alternatives to evolution, I did not find mentally deadening, but rather incredibly stimulating. And I basically went back and reassessed everything I ever knew. And I also support the idea of getting students to recognize the distinction between operational science and historical science. And for myself, as you point out, I often failed to make that distinction, even as a Cornell scientist, and I know that many of my colleagues have often failed to make that distinction. It's very important to distinguish them for this reason. Operational science must be reproducible. It's incredibly important. It's not science if someone else on the other side of the world can't reproduce your experiment. But historical science is not reproducible. Let me give you a quick illustration. It's often said that Josephine poisoned Bonaparte and Napoleon, okay? That's historical science. And they say, look, we have scientific proof that she did it because we found arsenic in the bones of the person who'd buried in Napoleon's grave. But I'd like to distinguish for you what part of that is operational science and what part is historical science. If we test for arsenic in those bones, you can send it out to 20 different laboratories around the world, and they'll all give you roughly agreement about how much arsenic is in those bones. That's operational science, and it's reproducible. Everybody can agree to it. But there's also historical science. Given the importance and political intrigue associated with Napoleon, was it Napoleon buried in Napoleon's grave? That's an inference. Was he exposed to arsenic by accident or on purpose? That's an inference. If he was exposed to Napoleon on purpose, was it his wife or someone else or himself? So there's a great deal of inference. If you were a novelist and you wrote about the story of how Josephine poisoned her husband, that's called historical fiction. The problem is historical science can easily blur into historical fiction because there's no accountability. It's largely speculation. Historical science becomes more and more uncertain and increasingly subject to error the further back you go and the more inferences that are made. And so very quickly, when you talk about very remote or very ancient events, you're talking speculation instead of science.
Dr. Robert D. Silvestro received his PhD in biochemistry from Texas A&M in 1982. He currently teaches classes in nutrition and has also taught courses in biochemistry. Dr. D. Silvestro has authored or co-authored some 80 peer-reviewed research journal articles.
One of the things I do now to a large extent is try to design pharmaceutical and nutraceutical interventions that affect biological processes for a desired purpose. So I think I bring a little bit of a different perspective to this whole issue because I'm actually trying to change biological systems by design, and I think that gives me a perspective on how hard it is to get what you want without getting a lot of side effects. And I find it hard to believe that even with me knowing a little bit about life processes and how hard it is for me to get what I want without getting bad consequences, that random processes could do a better job than all of us PhDs can do. There's the popular statement that nothing in biology makes sense in light of evolution. I challenge anyone to tell me any single area of biomedical research that one couldn't do if they didn't accept Darwin's current ideas. I'm waiting to hear it. I can't think of a single one, and that question's been asked to some people and they can't give me an answer either. So in my work, what I work on could be interpreted in light of some evolutionary theories, but it's not required that I hold a particular theory in order to do my work. I could believe in Darwin, I could believe in punctuated equilibrium, I could believe in spacemen, I could believe in intelligent design, and I'd pretty much do the work more or less the same way. I know people are saying, well, you can't bring religious prejudice to the table. Well, if I'm not mistaken, Newton, who's one of the greatest scientists of all time, started with the premise of God designed the universe, so it was his job to figure out a little bit about what God did. In reality, there are a handful of people that have really gone through the Darwinian ideas that have come to the conclusion that they make compelling sense. There are a few like myself who've questioned those ideas and have come to the conclusion that they make compelling nonsense. But the overwhelming majority of scientists have never even thought about the question. My own case, I was an undergrad in biochemistry. I changed some of my spiritual beliefs during college, but I thought the whole idea of evolution was pretty irrelevant. My feeling was, well, let's get through that pretty quickly so I can go on to the areas that are really important that I'm going to use in my job. And I really didn't care about the issue. And it really wasn't until I was in grad school when I saw that there was this double standard, that my research and almost every other research I knew of was subject to certain kinds of scrutiny. And when it came to origins issues, origin of life, origin of species, that these researchers seemed to get a pass on the kind of scrutiny that my research and pretty much every other person's research was subject to. So that was really what got me interested. But I think the overwhelming majority of scientists, of life scientists, have not really considered the area very critically. Most of us are too busy trying to design drugs, study agriculture, examine ecosystems, do whatever we do for our job, and we more or less take the word of what we were taught, that Darwin's ideas are very solid because that's what we were told, and we're busy doing other things now. One of the great arguments for the idea that there could be design in the origin of life is what's called ordered complexity, that you have order and complexity. I mean, you can have complexity, but it can be all gibberish. You can have order, like somebody saying, "Go Ohio State Buckeyes," but that's not really complex. But you can then have order and complexity where you have a Shakespeare play, for example, and the genetic code has got amazing ordered complexity in it. And no, I've never seen anywhere where anyone said we know how this came about. There are people that have ideas and hypotheses, but I've never even heard the most ardent naturalists say we know how life started, or we know the origin of the genetic code.
Dr. Daniel Eli holds a PhD in physiology from the University of Southern California School of Medicine. He has received the University Teacher of the Year, College Researcher of the Year, Distinguished Research Award, Outstanding Faculty Award, as well as a long list of other prestigious honors. Since 1976, he has been Professor of Biology at the University of Akron in Ohio.
I was raised in biology and chemistry with regards to evolution. I never questioned evolution. It was in the textbook. I was taught that. I went through biology. Evolution was it. I just never questioned it. It never came up. Until later in my life, I started getting questions about it, and my research started bringing up some red flags that I just personally was interested in. So if we could have the first slide. One of the things that's very unique about the Y chromosome is that it does determine male sex in mammals, but it doesn't have any kind of a pairing mechanism. In other words, there's no mechanism that it lines up with. All of the other chromosomes line up. Even the X chromosomes line up with each other with an X in the female. But in the male, you've got this Y kind of by itself in terms of being able to repair itself. It doesn't correct itself nearly like the other chromosomes do. And so of any of the chromosomes, it has the most mutations, has additions, things that have been added to it. It has deletions, things that have been taken out of it. It has inversions. It has repeat units. And so because it's so different, it's been used then to track male lineages. And so they actually used the Y chromosome to go back in time and look at Adam, or look at whoever the first male human was in time. And it's a good marker because it has lots of differences on it. The sex-determining gene is, for the male, is also on this Y chromosome. The name of it is SRY. It's in mouse, rat, man, for comparison purposes. It still functions the same for sex determination. But through our manipulation of a rat model looking at blood pressure, we have found there are 6 copies of this gene, which is kind of unusual. 6 copies on this Y chromosome. Next slide. Again, this is just to show you that there's some real science behind this. I don't expect everyone here to understand this, but over here are the copies. So SRY 1, 2, 3, and several variants of the third one. And what this is just looking at specific DNA sequences and where they're located. We've put section numbers for these so anybody can go into a website at GenBank and find these and look at what the differences are. So we have differences in 6 copies of a sex-determining gene. Does this mean that this rat is super rat? Is this rat really a super male? Or what's happening here? So next slide, we'll show you something quite interesting, that if we look at this SRY protein, the actual product that the DNA makes, it's more like human than the mouse. And if we look at the normal ancestor, we find that mouse and rat diverted. They had a common ancestor, but they diverted. So a mouse and rat are quite different. Physiology is different, a lot of different things about a mouse and a rat, not just size. But they should be quite related, and they should be equidistant from human, and they aren't. If we look at the amino acid differences, mouse to human has 4 out of the 6 amino acids in the gene we're looking at as different. Rat to human has only 1 of 6 of the amino acids different. It seems to be much, much closer. Again, it doesn't make sense if we're just following standard protocol on evolution, how this can happen. And of course, you can make arguments for this. You can make a hypothesis and argue from an evolutionary standpoint, macroevolution, this could happen. You can make it just so story that it could happen. But you could also say, no, it didn't happen. And you could look at design, say that's a hypothesis you want to look at. How was this designed? Why was it designed? Why, if we have millions and millions of years with a Y chromosome that can't really repair itself very well, you know what evolution predicts? That the Y chromosome is going to disappear because it doesn't repair itself like it should. I'd call that de-evolution. We're going to lose the Y chromosome. Lose the Y chromosome, guess what happens? School's out. I used to go around the university to honors colloquium and teach my hypertension, high blood pressure research, and they would ask me to come over and give that talk. Well, 2 years ago, I gave a talk on intelligent design and evolution, comparing and contrasting. And now they don't ask me for my hypertension research. That hurts. They want me to go out and talk about evolution and intelligent design. And I just got a call the day before I came here, totally unsolicited, by one of the honors instructors, and she said, this summer, can you do that same lecture? And I said, the hypertension one? No, we want you to give the intelligent design evolution one. And why is that? And he says, because the students write up a paper on what you present, and they get into discussing it, and they bring out the issues themselves, and they have a good debate and discussion with it. Yes, that's university students, but I'm not so sure they're that much different from high school students. And one of the things I do, I didn't have time here, but I show a slide, and we go through all kinds of data. And here's what evolution predicts, macroevolution. Here's what design would predict. And then let the students come up with the prediction. You can make those predictions, you can test them, you can see what the data shows, and then you make a decision. And the students come up with their decision. They're not influenced by the teacher. The teacher doesn't take a stand either way.
Roger DeHart has taught biology at the high school level for 28 years. Mr. DeHart taught intelligent design for 10 years without receiving any complaints. After a complaint was filed, he was not only forbidden from teaching intelligent design, but was forbidden from teaching any criticisms of Darwinism.
I supplemented the text in 1992 with a portion of Pandas and People. I would then allow students to critically analyze. I would always put this in the third person, saying that this was differing views from other scientists. And then I would allow students to either write a position paper stating 3 best evidences for or against Darwinian evolution, and then those students who would like to have the opportunity to debate the topic in front of the class. It was always done in an even-handed way. There was the same number of students for both sides. They had the same amount of time, and it was a good experience.
How did the students react to it?
Well, overwhelmingly, many students saw that as the favorite part of biology. Much of biology is merely restating of facts, of rote material that's in the textbook. This was an opportunity for students to critically evaluate, and they had a say, actually, in their opinion of what they thought.
And how long did you use that methodology?
I did that for 10 years.
And during that 10-year period of time, what kind of response did you get from parents?
Positive.
Could you amplify a bit on that?
I had positive up until 1997, and I had one complaint. The complaint was not lodged with me or the school district. It went straight to the ACLU, the American Civil Liberties Union. The ACLU then contacted my superintendent. I had to submit a handwritten summary of all that I was to say in the 2-week unit. And then finally I was reassigned to Earth Science. The person who took my job was a former student. He was a PE major. He had 0 years of teaching experience. I left the school district. My love is biology. I've taught that for 28 years. As I said, at that time it was 23 years. That's what I was trained to do.
Were the supplemental materials relevant to a comprehensive understanding of biological evolution?
The supplemental materials that I presented gave a different picture of the interpretation of the evidence than what was in my text.
Was that different interpretation relevant to student understanding of biological evolution?
Certainly, and I think that's what has been testified. Some of those issues, the origin of life, homology, and things like that have been spoken to earlier in this.
And you believe all those are relevant?
Yes, I do.
Can the student really understand biological evolution without having that additional information?
Well, I don't think they can accurately weigh the evidence. I mean, that's not what current science is showing, so they're giving a dated or misrepresentation.
And then you went from there to another school. Tell us about that.
Well, the other school was 40 miles south. That school, I was very upfront. I didn't want to be caught in the same situation again. I went in, had an interview. I was selected for the position. I told them right up front who I was. I told them of my controversy. I told them before I accepted the job that I still wanted permission to give the criticisms of the textbook and allow students an open education. I was notified by phone 3 days before I was to take the position that I had been reassigned again to Earth Science.
And where are you teaching now?
I teach at Oaks Christian High School, which is college preparatory high school just outside of LA in Westlake Village. I teach honors biology and AP biology.
And how do you teach it there?
We teach just the textbook version, and then once again we look at criticisms of the text and where they may have misrepresented the evidence, and then I present the case for intelligent design.
And how do the students
They enjoy it. It's always, once again, as I stated before, I think it's one of the best units that we have, and it just gets kids to be able to critically think, and that's what we as teachers want to do.
Do you think a public school system should prohibit teachers like you from teaching criticisms of evolution that would somehow weaken the theory?
Well, supposedly a scientific theory is supposed to withstand criticisms. That's why we have them. They go through, that's why they're repeatable, and that's the nature of science. It's supposed to be self-correcting mechanism because of the challenges that other scientists bring to it. So if it doesn't cut the mustard, it shouldn't be there.
Do you believe that when we don't understand the answer to something, it is appropriate to attach to it a supernatural explanation in science?
No, I do not, but if the evidence leads there, we should go there.
Are you aware of the fact that there is not a single major national or international scientific organization that agrees with you on that?
I realize that if anybody held the views that I did, they would no longer be a member of that group.
Please, no sign, please. Just confine your comments.
And is it your opinion that the reason that happens is because those organizations are biased against views such as yours?
A study put out in 1999 by Ed Larson held that the National Academy of Life Sciences, 95% of them, held a naturalistic view of the Earth.
But isn't the presumption or the hypothesis that is intelligently designed one based on opinion, philosophy, faith, the supernatural?
No, it's not, because I can't find a single piece of evidence where Darwinism would be falsified. I mean, we've seen that in junk DNA. That was supposed to be the thing that pointed right to common ancestry, and now we're finding that there's purpose in it. But yet Darwinism is not falsified.
Can you comment on whether or not it would be of value for students and of value for teachers to have the words instead of just use the word evolution, at least to try to differentiate between when they're using the word evolution, in what sense they are using it?
Yes, yes. That needs to be done. That's all I can say. Yes, emphatically.
Ms. DeHart, I thank you for your time.
Thanks very much.
Dr. John Milam received a PhD in computational chemistry from Rice University. Today, Dr. Milam works for a software company called SemiChem, where he develops computational chemistry software that can be used by chemists, biochemists, pharmaceutical companies, and material scientists.
I want to take a little time to explain the birth of modern science, because what's astonishing is that scientists are not taught about science. Scientists are taught about what science do, how to run experiments, but scientists traditionally are not told about what science is. We're taught about the discoveries of science, but little about the philosophy or origins of science. And the way I discovered this was after 5 years of undergraduate, 5 years of graduate school, and 3.5 years of postdoctoral work. I didn't know about how science began until a philosopher actually questioned me about that subject, and so I've had to learn it on my own. I did not learn any of this even at the highest levels of academia. Modern science really developed in the 16th and 17th century, but it has roots in the scholastic period, that's 11th to 15th century. Roger Bacon and Albert Magnus in the 13th century, they're the ones that first emphasized the experimental method. We have Francis Bacon and Galileo in the 17th century. They're the ones that really pioneered the scientific method. And finally, of course, we have the big names, Johannes Kepler, Isaac Newton, Charles Boyle, et cetera, et cetera, et cetera. These are the people that took this newly developed scientific method and applied it and actually demonstrated its effectiveness. There's nothing inherent in the scientific enterprise that requires restricting it to natural causes or natural explanations only. Science is about what is testable, not necessarily what is naturalistic. And kind of as supporting evidence for that, all the figures who founded and developed modern science, such as the people I've just mentioned, none of them held to this idea of methodological naturalism.
Do you believe science should be neutral as far as theistic issues?
I believe it should be neutral in all respects, neither favoring or disfavoring theism or atheism.
Dr. Nancy Bryson earned her PhD in physical chemistry from the University of South Carolina in 1982. Her entire 20-plus year career has been devoted to teaching chemistry at the college level. In 1999, Dr. Bryson received the Bear Hug Award at Shawnee State University, which is the equivalent to Faculty Staff Member of the Year Award.
In February of 2003, I was working at Mississippi University for Women, and I gave a presentation to our honors forum entitled Critical Thinking on Evolution. And the honors forum is a set of the most academically talented students at MUW. And in my talk, I presented some criticisms of evolution that I felt that the students might not have heard. And I also spoke about an alternate theory of origins called intelligent design. And the talk was very warmly received by the students. In the talk, I brought up some of the criticisms of evolution that I've been reading about. For example, the Cambrian explosion is often not mentioned in general biology textbooks at the college level, and I think that presents a big problem for evolution. I also talked about the origin of life scenarios and the unlikelihood that any of those scenarios, for example, the Miller-Urey experiment, they have very little relevance to anything that I know about. I basically talked, those were my two basic points in my talk, I guess, the origin of life scenarios and the Cambrian explosion.
And then what was the reaction?
At the end of the talk, the evolution professor stood and read a prepared statement. He brought in a prepared statement, and he talked for about 5 minutes, and the gist of his statement was that what he said, this is a quote, "This is just religion masquerading as science."
And then what was the reaction of the students?
The students very warmly had received the talk, and they were appalled at his diatribe against me in the talk. And that was about it.
You had a line of students come up to you?
I had probably 15 to 20 students come and tell me they had never heard any of that.
Okay. What happened the next day?
The next day was a Friday, and about 5 o'clock that afternoon I was in my office, and my boss, the Vice President of Academic Affairs, came in and told me that I would not be serving as division head the next year. And he suggested, though did not say directly, that I might not be on the campus at all the next year. My story was picked up by the American Family Association, and there was a big outcry in the state of Mississippi about the whole issue. But ultimately, I was dismissed from my division head position.
Do you feel like within the biology classroom there is academic freedom where teachers and students can candidly discuss this theory?
There is absolutely not academic freedom, and I, subsequent to my talk, students would come by and talk to me about that. And when they saw the battering I took, actually they were a little bit afraid to talk to me, so they would come by after hours. And they told me directly that you couldn't challenge, you couldn't you couldn't ask any questions in the evolution class. That's the truth. So on that campus, the whole incident had a very chilling effect, and I guess the chilling effect was already there, but my incident just brought it out.
That with which you talked is that generally classified or characterized as neo-Darwinian evolution?
Yes, sir.
Is methodological naturalism another way of stating a philosophical claim? Is methodological naturalism and another method of stating a philosophical claim?
Absolutely. Sorry.
Go right ahead.
My big point in my talk was you couldn't ever got the whole thing started. From my understanding of thermodynamics, there's no origin of life scenario, no prebiotic evolution scenario, no chemical evolution scenario that would have ever allowed for the self-organization of matter.
And so what do you base that on? I mean, what method of science, or how do you come to that decision?
My reading, and in my reading, it all made good sense to me thermodynamically. You just don't have that kind of self-organization occur. And there would be so many processes that would be occurring on the early Earth that would have prevented any self-organization. Dilution of amino acids in the ocean, the fact that amino acids combine in different ways, the fact that non-proteinaceous amino acids combine with proteinaceous amino acids. The whole scenario is utterly impossible, in my opinion.
How did you feel your students' education benefit or did not benefit from being allowed to discuss such things in any of your classes?
Well, I just think it's incumbent upon any teacher to present the pros and cons of any theory. And for example, in chemistry, in general chemistry, we always present two theories of chemical bonding, and we say, here's the pros of this one and the cons of this one, here's the pros and cons of this one. It's just amazing to me that we can't do the same thing in origin science. And the students, if you want to have a bunch of robots as your students, then you feed them just only the data that you want them to have. But if you want them to be critical thinkers, you give them all the data and let them decide.
So regardless of if the data has not been accepted widely in the community of science, it's still, do you think, very beneficial for the students to hear critical data?
Very beneficial, yes.
Thank you.
Dr. Stephen Meyer earned his doctorate in the history and philosophy of science from Cambridge University. He has written or edited 3 books, including Darwinism, Design, and Public Education, and Science and Evidence of Design in the Universe. Dr. Meyer is currently Director and Senior Fellow of the Center for Science and Culture at the Discovery Institute in Seattle, Washington.
Would you perhaps summarize briefly, Dr. Myers, your recommendations for a science, an appropriate science education policy for a public school?
But very simply, we recommend that neo-Darwinian evolution, your standards call it biological evolution, but the standard received theory of biological evolution today is still neo-Darwinism, though there are many competitors within the scientific literature. But the standard textbook version of the theory called neo-Darwinism is something that we think students should learn about. They should learn about the 2 main parts of the theory of universal common descent, and also the idea that natural selection acting on random variations and mutations has the power to generate new biological form. And further, students should also learn the current scientific criticisms of the theory as they exist in the scientific literature. So we think that students should learn the theory, they should learn its strengths, they should also learn its scientific weaknesses, and that the mode of instruction should be based on evidential concerns. That is to say, the starting point should be the evidence that scientists are using to either support or challenge the theory. I think that the definition of your minority report is much preferable, and I'll tell you why. You have made it clear that you are neither mandating nor prohibiting the discussion of intelligent design in your science standards. You've taken a neutral stance on that. There is, of course, however, a debate about the theory of intelligent design going on within the larger scientific community.
If you do not believe that human beings have a common descent with pre-hominid ancestors, what is your personal alternative explanation for how human beings came into existence?
I'm skeptical about the Darwinian account of such things, but that it wouldn't bother me if it turned out to be different.
All right.
I also would tell you that I think that humans and the rest of the non-human living world, that humans have qualitatively different features that I think are very mysterious and hard to explain on any materialistic account of the origin of human life.
Dr. Angus Menuge received his BA in philosophy from the University of Warwick, England, and his MA and PhD from the University of Wisconsin at Madison. Although born in England, he became an American citizen in February 2005. He is currently a professor of philosophy at Concordia University, Wisconsin, and associate director of the Krenach Institute.
On Roman numeral page 10 of the Kansas Science Standards, there is discussion of the nature of science, and the first sentence, this also is cross-referenced on page 4 of the Minority Report. Science is a human activity of systematically seeking natural explanations. Okay, so it's saying that you can only look for naturalistic explanations, which is what methodological naturalism says you should do. First of all, there is a problem because methodological naturalism is being used in the context of a controversy. Cut down to its absolutely most basic central claim, Darwinian evolution claims that all apparent design in nature is an illusion. It's something to be explained away. On the other hand, for example, intelligent design provides empirical scientific criteria for detecting design in nature. Basically, methodological naturalism says scientists should proceed as if there is no design in nature. So that prevents the Darwinian claim that design is an illusion from being tested. If you make the claim that design is an illusion, the only thing that could prove that you are mistaken is some evidence that would show that at least some of the design is real. If there can be, by definition, no such evidence, then there is no way to ever refute the claim that design in nature is an illusion. It's not, by the way, that the Darwinian claim itself is unscientific. It's perfectly scientific and it's perfectly testable. It is rather joining the Darwinian claim to methodological naturalism that insulates it from being tested, because it means that only the evidence that supports the theory can be presented, not the evidence that would count against it. So the argument I'm going to make here is that methodological naturalism does not properly inform students. The only way that you can properly inform students on a matter of controversy is to inform them of both sides of the controversy. But in fact, you have a single perspective. This would be analogous to what occurred with some companies like Enron, where you provide only positive financial indicators about a company and allow people to conclude that your company is in fact healthy, or notorious tobacco company scientists who presented only that evidence bringing out the beneficial results of tobacco. This is a failure of full disclosure, okay, and it's what's known in logic as the fallacy of suppressed evidence, where you make a conclusion seem much more certain than it actually is by only presenting that evidence which supports the conclusion, while suppressing the evidence which points in a contrary direction.
How do you explain the large number of theists, including evangelical Christians, who are scientists that do not see the methodological naturalism as a conflict with their faith?
Well, there's a couple of issues here. One is that the mere fact that you have somebody who holds two beliefs, A and B, does not show that they are logically consistent. So it might be that some of these people are confused. The other issue is, as this debate shows, this area is extremely controversial. So I expect they've worked it out because they've adjusted other of their assumptions in various areas. And some of my friends hold exactly the view that you hold. I don't think they're bad or stupid people.
Do most philosophers of science agree with you that they are basically the same in their effect, how they interact at the education level?
Well, I haven't surveyed them all sociologically, but it seems to me it's a logical inference. If you only present the evidence in favor of something, you are advocating it, even if you then say, oh, but you're free to believe otherwise. In other words, you're free to believe otherwise with no evidence.
So is neo-Darwinian evolution, as most evolutionists understand it, does it have religious connotations?
Yeah, it has religious implications, because if it's taken to be the full account of everything that we observe, it implies that nothing is designed or has a purpose, that human beings in particular are just occurrences, we're products of this random process, and that we have no preordained value, meaning, or significance.
Dr. Warren Nord received his PhD in philosophy from the University of North Carolina. He has written more than 30 book chapters and articles in professional and scholarly journals, primarily on religion and education. He also authored 2 books, including Religion and American Education, Rethinking a National Dilemma, which is considered by many to be the most comprehensive study of religion in secondary and higher education published in the last 50 years. Dr. Nord teaches the philosophy of religion and the philosophy of education at the University of North Carolina.
I started to write a book back in the mid-'80s on the humanities and the importance of the humanities to education. And the book was to have one chapter in it on religion, or more specifically on religious studies, as one of the disciplines of the humanities. Well, as I started writing that chapter, it got longer and longer, and before long it had taken over the whole book. And that became my first book, called Religion and American Education, Rethinking a National Dilemma. The book has the questionable merit, I suppose, of being the most comprehensive study ever done, I think, of religion and education, particularly secondary and higher education. One of the things that I've done is read over 80 high school textbooks in the sciences, in history, in economics, in health, in home economics, and virtually all of the national content standards that were issued primarily in the 1990s. And what I discovered was that neither in textbooks nor in the national standards was religion taken very seriously at all. Certainly, history textbooks and history standards include a fair amount of religion in the context of the fairly distant past, not much in the context of the 19th or 20th centuries. And textbooks and standards in all other disciplines virtually ignore religion. A liberal education should introduce students to the major ways humankind has developed for making sense of the world. Some of those ways are conservative, some liberal, some secular, some religious. Right now, public education is incredibly parochial. It basically only introduces students to secular ways of making sense of the world. It leaves religious voices out of the discussion. A typical way of thinking about liberal education is in terms of introducing students to various disciplines. So we have distribution requirements in college and in public schools, the requirement that students take history and literature, history and English, or we call them social studies and communication arts or communication skills, and science and math. But there isn't any requirement that within each of those areas of study, students be required to understand different ways of interpreting the subject matter. We simply introduce them, initiate them into a series of disciplines. Think if we only taught students how Democrats think about the world and never mentioned how Republicans think about the world. We all agree, I think, that that would be, well, maybe we don't. Most of us agree that that would be a bad education. To be educated about politics, you have to understand how Democrats and how Republicans think about the world. To be educated about economics requires understanding not just how neoclassical economic theorists understand the world, but how economics is understood within various political and ideological and religious traditions as well. We don't do that. Education isn't truly liberal. We make a feeble effort toward it. A few years ago, we thought that it was all right to leave blacks and women out of the cultural conversation. I think we now all realize that's wrong. But what we still haven't come to realize is that it's wrong to leave religious voices out of the discussion. The problem is the same. It's disenfranchising people. It's saying we're not going to take your values and your views seriously. The philosopher of science, Thomas Kuhn, who I think would be by clear consensus viewed as the greatest philosopher of science, the most influential philosopher of science of the 20th century, said in his most important book, The Structure of Scientific Revolutions, that scientists are educated the most dogmatically of any group in our society with the exception of theologians. He's wrong, of course. They're educated much more dogmatically than our theologians. No theologian can get through college or seminary without encountering a lot of science. Most scientists get through their PhDs without ever encountering any kind of religious studies or theology or philosophy. Let me put it this way. If there is a God, and God created nature, there must be design somehow or another in the world. That is, given most conceptions of God, God is good, and God would create nature to fulfill God's purposes. There must be design inherent in nature. Methodological naturalism does not, as Professor Manouche said, allow us to find any of that evidence for design. It rules design out a priori. It converts science from being an empirical discipline to a dogmatic discipline, one which is passed on to other scientists and to other students really as a matter of faith. Now, this isn't a totally unreasonable faith. Naturalistic science has worked quite well in a lot of regards. It's not surprising that scientists have a fair amount of faith that it will continue to work well in the future. But by excluding design explanations or teleological explanations, it asserts a priori that it will continue to work well, and that really is a matter of a kind of faith. That is a trust that what has worked well in the past will continue to work well. One of the things that really disappoints me is how this issue has gotten framed in terms of conservatives and liberals. The position I'm arguing for, it seems to me, is the liberal position. Science is notably illiberal, the scientific establishment in science courses. The idea of liberalism is including everybody in the discussion. I mean, that's what we went through with women and blacks and various ethnic groups. You include them in discussion. We left them out. We'd been illiberal. Now we've come to see through multiculturalism and all other kinds of of movements within education over the last several decades that was wrong. It was wrong. It is tremendously important to include them in the curricular discussion. That's the liberal position. That's not the conservative position.
Mustafa Akyol is a columnist in a Turkish daily newspaper and a freelance writer in the U.S. media. He is also Director of International Relations at the Intercultural Dialogue Platform, headquartered in Istanbul, Turkey. He was educated in political science and international relations at Bosphorus University of Istanbul.
Why I'm here, I should explain that. I'm coming from 6,000 miles away. I live in Istanbul, and why a debate on the science standards of state of Kansas is interesting for me. Well, it is very interesting. It's very important for me because I think this is an issue which will have implications beyond Kansas, beyond even the United States. It will have an impact in the minds of the people, and it will create a sense of what America is in the minds of people. And I could say in recent years, I can claim to be an expert on Islamic radicalism. That's what I write, especially in the United States, in the media, and in Turkey. We know that we have this big problem of Islamic radicalism, a widespread hatred of America and the West in general in the Islamic world. And it has many reasons, sociological reasons. It has some about the failure of the Muslim world in the 20th century. But one reason of the widespread resentment is that Muslims think that the West, and also, of course, the United States, is completely a materialistic civilization. They think that when they watch Western films, when they read the Western media, and when their kids take the Western education, they think that they will be poisoned by an ideology, materialism, and that's why they just don't like it. They just want to get away from it. And at the very extreme, it creates what we have anti-American sentiment among Muslim populations. And I remember that, for example, but when people get a sense of the U.S., and when they see that it is not like that, it's not completely materialistic, they might think differently. And again, in my childhood, I remember that one of the most popular TV series in the 1980s was The Little House on the Prairie. Muslim conservative families all loved it, and they said, oh, look at these American values, and they're so noble values, and they just admired it. And now times have changed. Now they see MTV, they see the Hollywood, and that's of course materialism in a cultural sense. Materialism in terms of hedonism and just caring about profit and don't having any ethical values. But materialism also has a philosophical side, and that philosophy is, as we all know, it's also called naturalism, the idea that nature is all there is. And when that philosophy, which has no scientific justification at all, becomes the dominant force in science education in the United States, what you have is that you will have alienated people. You will have, for example, Muslims. They will feel alienated. They will think that there is a school system which imposes on them, on their kids, a philosophy which they don't believe and which they find to be poisonous and which doesn't have any scientific evidence at all. That's the important point.
Did I understand you to say that the public perception in Turkey is that they have an understanding and that they know that these hearings are going on about the discussion of science standards in Kansas? Is that what I'm...
Definitely.
Do I further understand you to say that they are aware that this is about trying to achieve the best science standards free of religious and philosophical problems that the best we can achieve? Is that...
Yes, I think that's a good description of the perception in Turkey, I would say. Of course, not every person on the street knows about the debate, but it's been in the newspapers, and it will be more in the newspaper when there's a decision about this.
In Kansas, the perception generally is that we're trying to insert religion into the science standards. And that is categorically not what I am trying to do. And I just find that I'm a little bit amazed that that the media in Kansas doesn't seem to be able to portray that, and yet the media in Turkey is able to get that perception across. I just wanted to make sure that I understood what you were saying.
Well, there's a phrase I like. A Chinese professor said, in China, you can criticize the government, but you can criticize Darwin. In the US, you can criticize the government, but you cannot criticize Darwin.
Dr. Michael Behe received a PhD in biochemistry from the University of Pennsylvania. He has authored over 40 technical papers, as well as the best-selling book, Darwin's Black Box, The Biochemical Challenge to Evolution, which argues that living systems at the molecular level are best explained as being the result of deliberate, intelligent design. For the past 20 years, Dr. Behe has been professor of biochemistry at Lehigh University.
I'd like to start by saying that it's not just myself, not even just ID people, intelligent design people, but a number of scientists have been skeptical that microevolutionary processes, Darwinian processes, can explain larger patterns in biology and especially in the molecular biology of the cell. For example, Stuart Kaufman, who's a professor at the University of Calgary right now, wrote in a book in 1993 that it is not that Darwin is wrong, but that he got hold of only part of the truth. For Darwin's answer to the sources of the order we see all around us is overwhelmingly an appeal to a singular force, natural selection. It is this single force view which I believe to be inadequate, for it fails to notice, fails to stress, fails to incorporate the possibility that simple and complex systems exhibit order spontaneously. And this was published by Oxford University Press, an academic publishing house. Why are some scientists skeptical that Darwinian processes can account for what they see, especially at the molecular level of life? Because in the past 50 years, science has discovered, much to their surprise, and which was completely unknown in the time of Darwin, that the cell, the basis of life, is composed of machines, literally machines made out of molecules. This illustration up here is a cover from the journal Cell, which was published in 1998, a special review issue on the topic of molecular machines. And inside, on the table of contents, there are listed a number of articles, such as the cell as a collection of protein machines, polymerases and the replosome, machines within machines, mechanical devices of the spliceosome, motors, clocks, springs, and things. And the editor of this special issue was a man named Bruce Alberts, who is the president of the National Academy of Sciences. And in his introduction, he states, "We have always underestimated cells. Undoubtedly, we still do today. But at least we are no longer as naive as we were when I was a graduate student in the 1960s. The chemistry that makes life possible is much more elaborate and sophisticated than anything we students had ever considered. Indeed, the entire cell can be viewed as a factory that contains an elaborate network of interlocking assembly lines, each of which is composed of a set of large protein machines." Now, why is this a difficulty for Darwin's theory? He wrote that if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous, successive, slight modifications, my theory would absolutely break down, adding, "but I can find out no such case." Here he was insisting that his was a gradual theory. Natural selection had to improve things slowly, in many steps, over a long period of time. He knew that if things improved too quickly, it would look like something other than random processes were involved. Well, what sort of a system can't be explained or is very difficult to explain by numerous successive slight modifications? One which is irreducibly complex or has the property of irreducible complexity. This is a fancy phrase. It just means that you've got a system with a number of different components that interact with each other to produce a function beyond the system or beyond the components itself. And an example I cited in my book, Darwin's Black Box, on this from our everyday life is a mousetrap. A mousetrap has a number of different components, such as a spring, holding bar, catch, and so on. And it needs all these components to work. If you take away the catch, if you take away the spring, if you take away the holding bar, it's not that it works half as well as it used to, it's broken, it doesn't work at all. Now, things like this are a problem for a gradual theory like Darwin's because because the function of an irreducibly complex system only appears essentially when the system is complete. In intermediate stages, there's nothing for natural selection to select. And after it's finished, there's not a whole lot for natural selection to do. So things like this are challenges to Darwin's theory of gradual evolution. So are there any such irreducibly complex systems in the cell? And I argue that there are many of them. Yes, they're all over the place. This is the bacterial flagellum. It is quite literally an outboard motor that bacteria use to swim. It's got a number of different components, like a propeller, which actually pushes against the water and pushes the bacterium forward as the rotor spins. There's a hook region, which acts as a universal joint to attach the propeller to the drive shaft. The drive shaft is attached to the rotor, which uses a flow of acid from the outside to the inside of the cell. There's parts that act as a stator to keep it clamped onto the cell membrane, just like an outboard motor has to be clamped onto a boat as the propeller turns. And there are many other components as well.
In the first paper that you did with Dr. Snoke, what was the bottom line conclusion of that? Could you sort of simplify that?
The bottom line was that a process called gene duplication, where a gene coding for a particular protein is duplicated and is free to accumulate mutations, is unlikely to lead to new protein features which require more than a couple amino acid changes to produce them. Once you go beyond just one change to lead to the new feature, and you need 2 or 3 or 4, which is the case if you need to develop a new specific interaction between two proteins, then the expected amount of time that would take in reasonable population times starts to become prohibitive, over 100 million generations and higher.
And how many members of the population in that 100 million generations?
Well, again, it depends on the number of loci, but if you consider about 6, which is roughly the number of amino acids involved in a specific interaction between two proteins, it would take on the order of 10 to the 21st or so, which is would be prohibitive for virtually any organism except a single-celled organism.
10 to the 21st?
Yes. That's a big number.
It is important to keep science and religion separated, correct?
No, no, it's a very complex business. By that example, I was trying to say that what some people think to be religion at the time may turn out to be understandable later on. But if you rule out an explanation which seems to describe the data pretty well because it seems to have unwelcome philosophical or religious overtones, then I think that does science a disservice.
These hearings have been an unjustified waste of taxpayer money intended first to justify the board's support for inserting creationist claims into the science standards and to provide a showcase for the national intelligent design movement. The minority report and witnesses have misrepresented many educational issues, including the role of standards and the draft 2 position on teaching students the skills of scientific inquiry.
Mr. Iraganagorai's testimony lasted about 1 hour and 45 minutes. It ended with his refusal to submit his presentation to any questions.
Your duty is to carefully look after the dollars that Kansas taxpayers work so hard in order to pay the state. You have a responsibility that is much greater than each of you individually. You have a responsibility to the children and the future of the state, a responsibility that you have sadly failed. This was a gigantic waste of money and an insult to Kansas teachers, with great potential harm to teachers and students. I stand here as counsel for Draft 2. I am not a witness, and therefore I will not stand for questioning.
Given the breach of the rules by the opposing counsel, the rules being that we would have an opportunity to cross-examine for an amount of time equal to half of their presentation time, which would be approximately an hour. I don't have any problem if he doesn't want to answer my questions, but I do think, given the fact that I should have an hour, I should have the opportunity to respond to what he has just said. What is so significantly absent from the majority case is the data. Where is the data to support the claim of evidence so overwhelming that there can be no dissent? So the case for the majority simply is completely and totally empty. There is no evidence, there is no data, only oratory. Look in your dictionary for the definition of the word boycott. Boycott is a mechanism designed to coerce silence. It's a mechanism to intimidate. And so what is happening here is that you're seeing those in positions of authority seeking to discourage and intimidate scientists from stepping forward and stating what is in their minds, what is in their heart. It is ugly. It is really ugly. This is what the strategy is. Quote, the strategy at this point is the same as it was in 1999. Notify the national and local media about what's going on, all of you in the audience, and portray them in the harshest light possible. Dr. Harris is the most humble guy I think I've ever known, and his brilliance is just mind-numbing. The guy is an internationally recognized scientist. He is doing work that could affect the lives of everybody in the entire world in a very positive way. And he is being derided as an ignoramus, as an unprincipled bully, as a breaker of rules. There may be no way to head off another science standards debacle, but we can sure make them look like asses as they do what they do. This is not by ID scientists. This is a compilation of about 17 articles of molecular biologists and biochemists. And at the beginning of the book, they raised 26 issues that evolution cannot explain. They're not being able to explain with natural selection. And they start off. The very first question is, why did metazoan body plans arise in a burst? How did we get all of these body plans very suddenly? And what is the policy of the National Science Teachers Association? Do not adopt any policies that will suggest to students that life arises suddenly rather than gradually.
You see, we can't show them any evidence that violates Darwin's prediction that diversity arises in a purely gradual way. What the problem is the fossil record is really inconsistent with that prediction. I have Greg Lassie. I have Ed Sisson. And these guys are being painted as ignoramuses, as unprincipled bullies. Anybody who criticizes evolution. Jill Gonzalez Bravo was in fear, was literally in fear to come and testify here. That is a situation that our society should not tolerate. So thank you for this opportunity to speak and to give my closing argument.
Members of the Kansas State Board of Education Subcommittee on State Science Standards are Ms. Connie Morris, Ms. Kathy Martin, and Dr. Steve Abrams, Chairman.
Mr. Irgonagaray put up a PowerPoint that said that scientists will not participate because it gives the veneer of respectability. This would seem to indicate that science is more about obtaining respectability and not about seeking the truth. Obviously, if all the science was on the side of the evolutionists, they would come and embarrass the scientists that made presentations last week and those of us on the board by completely destroying the scientific evidence presented last week. Alan Leshner was quoted as saying, "Scientists love to fight, they love to argue in public, and they love to refute each other's point of view." If you look around the room, there's a lot of people here, a lot of cameras here. This seems like a pretty public place, a good place to have a debate about the evidences in science, particularly when that's what we're looking for. But indeed, no, such is not the case. What does happen instead is boycott.
As a teacher for over 31 years in Kansas public schools, I did applaud and cheer for the outstanding young science teacher from Rose Hill as she presented her experience in college classes and her classroom, and the educator from Ohio who's been a leader in helping his state to address this issue. The board has been accused of being closed-minded, and these hearings as being rigged. I guess we'll leave it up to the public, who might be the jury in this matter, to answer some of the questions that I would have liked to ask the council based on what we've heard these 4 days. Which side of the issue is being closed-minded?
I've taught in the public schools for 9 years, and I am a Kansas licensed teacher. I've sat through numerous teacher in-service sessions and prepared thousands of lesson plans. I assure you, teachers need clear direction on legal boundaries in the classroom. In fear of retribution, teachers err on the side of silence, which could mean a weakened education. Teachers need clear authority to present criticisms of evolution.
That concludes these hearings. I thank you for attending.